Okay, so this is a huge idea in calculus, is the idea that you can have equations with differentials, dy's and dx's, and so these are equations that can be solved, just like we can solve equations in algebra, we can solve equations in calculus, and so these are called differential equations. Differential equations are a big deal. They have a huge application in every branch of engineering, in physics, in financial engineering. They're so useful, and what's so cool about differential equations is that when you solve them, you don't just get a number like we do when we solve algebra equations. When you solve a differential equation, you actually get a function, or in this case, a family of functions, a family of possible functions. Now, later on, we'll do some of these where they give us boundary values or initial conditions, and those will allow us to find a specific function as the solution. So, a lot of great applications. Let's take a look at example 5. Here they tell us f prime of x is equal to 2x minus 1, and they tell me that the initial condition here, f of 2, is equal to 5. This is going to help me figure out what my actual constant of integration is. But first, let me rewrite this. So what I want to do is instead of f prime of x, let me write this using the Leibniz notation. dy dx is equal to 2x minus 1. And so, we can now multiply through by dx. We get dy is equal to 2x minus 1 times dx in parentheses. So the dx is being distributed across both of those terms. And at this point, I want to solve this equation for y. And to do that, I have to undo the derivatives. I have to undo the differential. So the integral of dy gives me a y. And here is my problem. 2x minus 1 dx. And we know how to do this. So what we get is y equals, and so this will become 2x raised 1 to 2 divided by 2 minus 1. And then x to the 0 becomes x to the 1, or 1x, and then plus c. And so we get y equals, the 2's cancel, x squared minus x plus c. And at this point, we can use our initial condition because we know that when x is equal to 2, y is equal to 5. So let me substitute 5 in place of y. Let me substitute 2 in place of x. And let us solve for c. And so we get 5 is equal to 4 minus 2 is 2 plus c. So then that means that c has to be equal to 3. And so that means that y equals x squared minus x plus 3 is the solution to our differential equation.